Here we will discuss how to apply Lagrangian interpolation formula to solve problems. So starting with the first one, given the following table, find fx assuming it to be a polynomial of degree 3 in x. Assuming fx as a polynomial of third degree, where the table is x runs from 0, 1, 2, 3 and y is 1, 2, 11, 34. Okay, by using Lagrange's interpolation formula. Now check here, the arguments are equidistant, but this is not necessarily for all the problems. Okay, it might or might not be equispaced. There is nothing to do actually with the equidistant arguments, where we want to use Lagrange's interpolation formula. So our formula is Lx equals summation of r equal to 0 to n wrx f of xr, right? Now putting the value of wrx, r equal to 0 to n, wrx is wx by x minus xr into w dashed xr and keeping f of xr same, right? Now check, in wx there is no r, right? So we can keep it outside the summation sign. That means we can write it wx summation r equal to 0 to n f of xr by x minus xr into w dashed xr, right? Now we will use this as the formula, and we are naming the denominator as dr. So we are writing it like this, by dr, where dr is x minus xr into w dashed xr. And what is wx? We have already defined in the theory part. Wx is x minus x0 into x minus x1 dot dot up to x minus xn, and dr is x minus xr into w dashed xr. That means it will become x minus xr into xr minus x0 into xr minus x1. There will be no rth term, that is xr minus 1 into xr minus xr plus 1 up to dot dot xr minus xn, right? These are wx and dr, and we have the arguments and entries as x0 equals 0, x1 1, x2 2, x3 3, and their corresponding values are y0 equals 1, y1 equals 2, y3 11 and y4 34, right? These are the all informations we have. Now we have to find out the table. So for that reason, at first, for the first column, we are choosing this column for x0. So we are writing, for the first position would be for x0, then the next position will be for x1, then for x2, then for x3, right? So the first position we are writing x minus x0. Then for the next position we are writing, this is the column is for x0 only, okay? That means here we are subtracting x0 from all the other terms. That is x1 minus x0, then x2 minus x0, then x3 minus x0. Now x0 minus x0 we cannot write it, otherwise it will become 0. So for that part we are writing x minus x0. Okay, this is the column for x0. Now the next column will be for x1. Now whenever this is the column for x1, that means we will subtract x1 from each of the term. So the first position we are writing x0 minus x1. The next is for x1, but it will become 0 if we write x1 minus x1. So we are writing x minus x1. Then next one for x2, x2 minus x1, then x3 minus x1. Okay. The next column is for x2. So it will become x0 minus x2. then x1 minus x2, then for x2, so it will become x minus x2, then x3 minus x2. Similarly, the next column for x3, so it will become this. Okay, now we will put the values later. And the next part is for dr. dr means the product of all this row. Now before finding dr, let's find out these values. Just put the values. This is x minus x0. Now value of x0 is 0. We already have this in our hand. So x minus x0 equal to x. Then x1 minus x0, this will be equal to 1. Just put the values x1 and x0. Next is x2 minus x0. That is 2 minus 0, which is equal to 2. Then x3 minus x0. That is 3 minus 0, which is equals 3. Next, for the next row, x0 minus x1. That is 0 minus 1. So minus 1. Then x minus x1. That is x minus 1. Next value will be 1. Then 3 minus 1, that is 2. Similarly, all these other values are minus 2, then minus 1, then it will become x minus 2, and it will become 1. Then minus 3, it will become minus 2, then minus 1, then x minus 3. Okay, these are the table. Now we have to find out the next column, which is dr. dr means row product. dr equal to row product. So find out the product of each row. That means multiply x minus 1, minus 2, minus 3. What will be the result? It will be minus 6x. Then multiply 1, x minus 1, minus 1, minus 2. It will be 2 into x minus 1. Next, multiply 2, 1, x minus 2, minus 1. It will be minus 2 into x minus 2. Then multiply 3, 2, 1, x minus 3. So it will become 6 into x minus 3. Okay. Next column will be for YR. YR means the entry points. So write down all the entry points. We already know it given in the question. These are 1, 2, 11, 34. Okay. Next column is for YR by DR. Because in the Lagrangian function, under the summation, we have the function f of xr by dr. f of xr and yr are same. So the next column will be for yr by dr. So it will become 1 by minus 6x, that is minus 1 by 6x. 2 by 2 into x minus 1, that is 1 by x minus 1. 11 by minus 2 into x minus 2, that is minus 11 by 2 into x minus 2. Next is 34 by this, so it will become the same thing, 34 by 6 into x minus 3. Okay, this is the rule for computing Lagrange's interpolation table. Now let's find out Lagrangian function. Now wx, we already have x into x minus 0, x minus x0 into, okay, I'm writing it again. This one, we don't have another terms. So put the value, it will become, right, and Lx equal to Wx, then summation to n yr by dr. Wx is this one, and summation of yr by dr. We have already computed the values of yr by dr. This is our yr by dr. This total 4 values. Summation of this total 4 values. That is summation of the last column of our table. So this will be under a bracket. At first minus 1 by 6x plus 1 by x minus 1 plus 11 by 2, minus, there will be 1, 2 into x minus 2 plus 34 by 6 into x minus 3. this one. Okay, this is our Lagrangian function Lx. Now we have to simplify it. Just find the LCM of this product of this part in the bracket. So LCM will be x in 6 into x minus 1 into x minus 2 into x minus 3. These 4 terms will be cancelled out with this. So it will become 1 by 6 into just doing the sum. This one. Okay, this is our required polynomial. If you simplify it, you will get the result x cube plus x square minus x plus 1. So this is our Lx, required interpolating polynomial, and which is equivalent to fx.